Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Guggen and I'm joined by Sana and will be your host this evening, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. Tonight is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. Go to www.yorku.ca/science/observatory and follow the links to OPV and join the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter with our handle at York Observatory or Instagram at YorkU Observatory. All of our programs are free, but if you would like to make a donation, please see our website at yorku.ca/science/observatory. We'll be monitoring our chat room for questions, and we'll also be posting photos that go in concert with our show tonight. So we don't really have great weather in Toronto today, Sana, do we?
No, it's been absolutely terrible for a few days now,
Yes.
unfortunately.
On and off rain has caused us to kind of lose out on our 1 meter viewing time tonight.
Unfortunately, yes.
What else is new?
Yeah, with Toronto being absolutely terrible is unfortunately a reality of life here.
It's been so predictable lately. I feel like if I don't leave my house with an umbrella, it will absolutely rain.
Yeah, that's about right. Yeah, the weather,
Well,
it always just seems to pick whatever is the most inconvenient for astronomers. So,
yeah, there's never a scheduled viewing night well, rarely do we get a full night of scheduled viewing. Usually we have to shut down early or we have to start late. Something's up with the weather.
yeah, we did get lucky a couple times in the past couple weeks, and we were able to stay up all night, and the equipment more or less worked. And I feel like I should be knocking on wood. I shouldn't even be saying this because it will upset the equipment. But
it's okay. We're far enough away that it can't hear you, at least today.
Yeah, we were pretty lucky, and we did actually get a couple like full nights of observing in with the new system, which is pretty fun. We're actually programming observations now, and we had it going from one target to the next all by itself. It was really nice.
What a way to go.
Yeah,
I
that'll
don't really take nights like that for granted.
No. That'll be super helpful for the next Messier marathon that we do.
Oh my gosh. You know, I actually was looking at some of the Messier marathon qualifications, and some certifications actually exempt you from a Messier marathon if you use an auto tracking telescope.
Yeah, I think that's
unfortunate, but we should just take out one of the old 10 centimeter scopes, take it out to the Arboretum, just wing it.
Yeah, that would be much more challenging.
No navigation whatsoever. I have no idea how people do that. It's impressive.
Lots of practice, I guess. If you've been doing it for a few years, you probably get the hang of it. But
that's true.
Definitely not something I can do.
No, me neither. I think the only thing I can absolutely find is the Ring Nebula.
Oh yeah.
That's it.
Orion. I can find Orion, but I can't find the Ring.
Okay, yeah. Orion is a gimme as well.
Yeah.
But yeah, I think you're starting us off with a shuttle launch today for this week in astronomy history.
Yeah. So July 26th, back in 2005, was the launch of STS-114 with the Space Shuttle Discovery. And all of the space shuttle launches are awesome for their own unique reasons, but this space shuttle launch was special, was particularly special because it was the return to flight, so the first space shuttle launch ever since the Columbia space shuttle disaster over 2 years prior. And what happened with the Columbia disaster in February 2003 is there was some kind of debris that had fallen off the side of the space shuttle, and it actually damaged the heat shield, I think it's called, on the space shuttle Columbia. So when the space shuttle went to re-enter the Earth's atmosphere, it actually broke apart and disintegrated and killed all of the 7 astronauts who were on board. So there was an over 2-year hiatus on space shuttle flights so that NASA could investigate the cause of the disaster and figure out ways to prevent it. But eventually all of that kind of culminated with STS-114, which was the first launch ever since the Columbia disaster. So there were 7 crew members, just like many of the shuttle missions, which were Commander Eileen Collins, which, by the way, Eileen Collins was a female mission commander, and this was only the second space shuttle flight to fly with a female space shuttle commander. There was also pilot James Kelly, and then 5 mission specialists, including Soichi Noguchi from JAXA, so I think it's the Japanese Space Agency, Stephen Robinson, Andrew Thomas, Wendy Lawrence, and Charles Camarda, who were all NASA astronauts apart from Soichi Noguchi. So one of the things that that STS-114 was set to accomplish, as with a lot of the shuttle missions, was like an ISS support kind of mission. So it was a resupply mission, and they also ended up extending their stay so that they could help do some ISS station maintenance and also boost the ISS orbit by quite a few thousand kilometers, which is something they have to do periodically to actually keep the ISS from deorbiting itself. Just because of drag in the Earth's atmosphere, they periodically have to lift its orbit up so that it stays at the desired altitude. And especially in terms of station maintenance, the space shuttle program was very important for that kind of station maintenance. And even for station construction, the space shuttle really assisted a lot in station construction and maintenance. So the fact that they hadn't been flying for 2 years kind of put a dent in the amount of maintenance that was able to be done over those 2 years at the ISS. So yeah, it was a resupply mission. They also assisted with a lot of the station maintenance that had been, I guess you could say, falling behind the past couple years. But probably the biggest, or sort of the most important part of this mission, was sort of to test and demonstrate some new safety techniques that had been brought into place after the Columbia disaster. So primarily just sort of inspecting the outside of the space shuttle to make sure that it wouldn't disintegrate when it tried to re-enter like Columbia did. And included in this was some new inspection techniques, which of course used the wonderful Canadarm to inspect the outside of the space shuttle. There was sort of like high resolution cameras that were able to observe different parts of the space shuttle. And there was also this laser equipment that was also able to find any sort of damages to the space shuttle that had happened to it during launch. And as a part of these inspection techniques, it did sort of recover a bit of damage to the exterior of the space shuttle by some pieces of something that had fallen off of I think it was the upper stage of the rocket when it was launching, and actually done some minor damage to the space shuttle, which was particularly concerning because that is what caused the Columbia disaster. The NASA engineers didn't think it was as severe as the instance as what happened to Columbia, so it would have been able to re-enter the Earth's atmosphere safely without worrying about the space shuttle disintegrating. But of course, they still actually did demonstrate some of the new repair techniques that had been developed over the past couple years. And they did this during a couple of different spacewalks. They actually went and repaired parts of the space shuttle that had been damaged during launch, which was the first time that something like that had been done, where astronauts had gone and repaired the exterior of the space shuttle during an extravehicular activity or a spacewalk. So they had 3 total spacewalks during this mission. There were a couple of them that were devoted to this sort of exterior space shuttle repair. They also installed this external stowage platform during one of these spacewalks as well. So this was definitely an important flight in terms of space shuttle history, because it did demonstrate some of these new safety measures that had been sort of designed during the past couple of years between the Columbia disaster and STS-114. But another important part of this mission was that it actually led NASA engineers to further postpone further shuttle launches. So instead of bringing them right back into circulation at the normal cadence of previous shuttle missions, they actually stopped all shuttle launches for another year to further investigate the issue with stuff falling off of the rocket and damaging the space shuttle. Thankfully, they landed safely, so the damage that was done to the outside of the space shuttle was not that bad. They were able to successfully perform these repairs, and the crew did land safely at Edwards Air Force Base on August 9th, 2005, which was the last shuttle mission for around a year until July of the next year, when that issue had been more dealt with properly.
Wow. So how often were the STS missions going previously to the Challenger disaster?
I don't know exactly, but I know it was more than like once every year.
Yeah, because I guess they had standard restock missions for the ISS.
Yeah, I know now those crew rotations are about once every 6 months. So I would imagine that it was more often than that, because a lot of the space shuttle missions, like a lot of them did dock to the ISS and helped with ISS maintenance and everything, but there were also quite a few space shuttle missions that deployed cargo from the cargo bay of the space shuttle. So I would imagine that they would be more often than the 6-month crew rotation that's sort of normal now.
Yeah. Okay, well, yeah, that's I definitely see why they grounded the fleet. Like, it was a huge, huge disaster.
Yeah, especially because this was the second space shuttle disaster following Challenger. So,
Yeah.
you know, if it happens a second time, like, yeah, you really need to investigate what's going on.
Yeah, I mean, it's like when Boeing had to have their entire fleet grounded of the the Max 8,
Yeah.
737 Max 8s. Like, you just can't fly after incidents like that happen, because, lots of people you're putting at risk.
Yeah, especially when they did observe the same thing on STS-114 of like, the damage wasn't as bad as with the Columbia disaster, but, especially showing that it is still a problem that's happening, and conceivably it could cause severe damage again in the future. Like, yeah, that's something that actually has to be dealt with.
Yeah, any damage, too much damage.
Yeah.
When you're doing a space mission, like, there's not much margin for error.
No. So, yeah, that was, so thankfully there were no more fatal shuttle accidents after Columbia. So it looks like the safety precautions that they put in place after that worked. And there was no more damage done to the space shuttles, thankfully.
Very thankfully, yeah. Okay.
Yeah, well, I think you have a really interesting This Week in History item going way, way far back past 2005.
Oh, yeah, we're going back to classical astronomy, just hanging out with a telescope with a bunch of buddies, and the telescope is just 2 pieces of glass. I'm kidding. But so I'm taking us all the way back to 1851, when a solar eclipse was imaged for the first time. This one kind of threw me for a loop, because I didn't know exactly what the early stages of photography went. So when I looked into this, it kind of gave me an opportunity to learn about that. So solar eclipse happens when the moon passes between the Earth and the sun, resulting in the sun casting a shadow of the moon on certain parts of the Earth. They're not a super rare occurrence, but total solar eclipses are a little more rare and exciting to see, as only small parts of the Earth will experience the total solar eclipse, where the entirety of the sun is covered by the moon, besides like the corona. And I will just shout out a little disclaimer here. If you have the opportunity to view a solar eclipse in your area, please do not look at the sun with your eyes, because you will burn your retina. You got to use a pinhole camera or special eclipse glasses. or, a telescope with a really powerful solar filter on it, just please don't look right at it with your eyes. Your retinas will thank you. But yeah, so this is a pretty big event in 1851. It was like, we consider total solar eclipses huge events here too. And back in I want to say 16 it was, or 17, we had a pretty big one here, and the observatory held a huge event for it. But back then, cameras weren't what they are today. You couldn't just, Google solar eclipse picture and have one for you in a blink of an eye. As there was a specific type of photography called the daguerreotype process that was required to create images. And this process took a lot of work, and not a lot of people were very skilled in the process. So it was also like super resource intensive. They had to expose a light sensitive silver plated copper mirror to a light source inside a camera, and then chemically treat it for the image to appear. So, you only have one shot at imaging this eclipse, and if it didn't go well, you wouldn't even find out until after it was over. So, one of the individuals who was really skilled at daguerreotype process photography, Julius Berkowski, was commissioned by the Royal Prussian Observatory at Königsberg to photograph the solar eclipse that day. And he, along with a team of observers, took the image on the silver mirror, and it was taken through a small telescope for a total of an 84-second exposure, which seems like a crazy amount of time if you've ever imaged the sun before, considering how bright the sun is and how easy it is to collect light from an eclipse. But back then, that was what was needed to create a pretty awesome photo. If you have the chance to go look it up, we might be showing it on our online public viewing, but it's the solar eclipse image from July 28th, 1851. Pretty great achievement.
Yeah, that's you said what it was, 84 seconds?
Yeah, over a minute.
Oh my God.
For the sun.
Sorry?
For the sun.
Yeah. Like you said, you can't even look at that with your eyes for even like less than a second, or you'll damage your eyes. But I honestly feel kind of spoiled sometimes when I hear about the way that astronomy used to be done many years ago, because we kind of have it easy with the 1 meter.
Oh, we have it so easy. And one of the things that made this a really tough method of photography, especially with a solar eclipse, is the super high contrast zones of the moon and the corona of the sun, which, I mean, back then they didn't even know that it was part of the sun. They actually kind of figured it out. There were a few other observers who were up at the observatory assisting him with his imagery and also observing the eclipse for themselves. And they were the ones who deduced that the projections coming out of the corona area of the eclipse were part of the sun. And they were like solar flares. But prior to this, we didn't know that either. So, yeah, because they figured that out because when they moved, when the moon moved, it covered up and revealed certain parts of the corona, and they were like, "Hey, that's actually the sun. That's part of it."
Yeah, that's the corona. I have never seen a total solar eclipse, but my favorite pictures of any solar eclipses are just the gorgeous corona that surrounds the sun. It's just absolutely magnificent. I can't imagine what it's like to actually see it in person.
Right? And the craziest thing is that they actually got the corona in this image.
Oh, wow.
Like, you can see it's not just like a black circle and then a bright field. You can see like details, which is astounding.
Wow, so the 84-second exposure is definitely worth it.
Totally worth it. And like silver plated copper that was fume treated to make it photosensitive, a whole crazy process.
Yeah. Wow,
first you have to manually polish the silver mirror to be like a mirror finish. It's like just regular silver poured on top of this copper, and then you have to polish it yourself.
Oh man.
Yeah.
We really are spoiled with the meter.
I know. Like, and now I can just take a photo with my phone.
Yeah.
Yeah, good times.
Oh, yeah. Well, while we're on the topic of the sun, one thing I want to mention is, and this is a little bit random, there's a, with the wildfires in Quebec and BC,
Yeah,
how red the sun has been looking lately on.
yeah.
So I've seen a couple people excitedly posting online that you can see sunspots with the naked eye because the smoke is so intense that it's actually blocking out that much light that if you look at the sun, you can see sunspots. I just would like to warn anybody who's listening, don't do this. I know you can see it with the naked eye and it doesn't actually physically hurt your eyes, or you don't register that to look at the sun when there's that much smoke in front of it. But please remember, there is still a lot of UV radiation that can pierce the smoke clouds and burn your eyes, and you will not know until it's too late. So, yeah, just like you said before, never look at the sun. And even if you think it's safe to look at through a bunch of smoke clouds, still don't. It's not safe.
Yeah, just because you can doesn't mean you should.
Yeah.
Your eyes will thank you. I would love to retain a whole retina throughout my youth and beyond. Get a good pair of sunglasses, I promise. Sunglasses, like big sunglasses, did not sponsor this propaganda. But you should get a good pair of sunglasses. Protect your eyes, people.
Yeah. And never look at the sun, ever.
No, not a good idea. Okay, we're going on to darker, smaller things in the Kuiper Belt now.
Yeah, so this is back to another 2005, but a couple days later, July 29th, 2005, which was when I think it was NASA announced the discovery of dwarf planets Eris and Makemake. So this is just a pretty interesting sort of discovery on its own, because these were some of the first dwarf planets that had ever been discovered. They were not actually discovered on July 29th, 2005. They had both been discovered in the months or years prior to that. Makemake was first observed in March 2005, and then Eris was first observed in October 2003, both by the Palomar Observatory. And then people from the same research group working on detecting, I guess, these dwarf planets, including professors from the California Institute of Technology, Gemini Observatory, and Yale University, ended up discovering these dwarf planets in or about 2005. At the time of their discovery, before they were announced, I guess everybody wanted to talk about Eris and Makemake, but they didn't want to sort of reveal anything. So they had code names or nicknames for both of these dwarf planets. Eris was originally nicknamed Xena, and then Makemake which is my favorite, had a code name Easter Bunny, because it was discovered not too long after Easter. So I think Easter Bunny is just, I don't know, that's super cute. Astronomers are terrible at naming things, but I think they should have kept Easter Bunny for Makemake. But anyways, both of them, once the discovery was made official, were of course renamed to be in line with the normal naming conventions that the International Astronomical Union has for astronomical objects. And because of that, Makemake was named Makemake after the god of fertility, and then Eris was named after the Greek goddess of discord and strife. And that turned out to be a very fitting name for Eris, because it caused a lot of problems for astronomers, particularly astronomers that study the solar system. And the reason for this is because, like I said, Eris and Makemake were some of the very first dwarf planets to be discovered. And there was at the time another dwarf planet that was considered to actually just be a full planet, Pluto. So when Eris and Makemake were discovered, it sort of begged the question of, how do we classify these things? Do we classify them as planets because they're similar to Pluto, or do we give them their own different designation? And if we give them a different designation, why doesn't Pluto have that designation? Because remember, Pluto is quite similar to Eris and Makemake. It's in the Kuiper Belt, and shares some other kind of kind of properties with both Eris and Makemake. So it sort of triggered a debate in the IAU, the International Astronomical Union, about whether or not Pluto should be a planet and what to do about these new dim, cool things that have been discovered recently. So there was a big discussion surrounding this. And one of the main points of interest in this discussion had to do with Eris in particular, because at the time it was discovered, astronomers believed that it was much, much more massive than Pluto. We now know that that's not true. Eris is about the same size as Pluto. It's a little bit smaller, so it's the second biggest dwarf planet in the Kuiper Belt next to Pluto itself. But it is 3 times further away from the sun than Pluto. And I guess people just kind of mistook its size to be bigger than Pluto. So it was sort of that point in particular that caused a lot of arguing about, like, how do we classify this? And after about a year of discussions, and the IAU made a whole committee to kind of come to a conclusion about what to do about this, a year later, in August 2006, they announced that Eris and Makemake and some of these other dwarf planets that had been discovered in the meantime should be classified in this new classification of dwarf planet, and Pluto would also fall into this dwarf planet designation. So for the first time, they kind of came up with rules about what constitutes a planet and what constitutes a dwarf planet, and it turns out that Pluto is a dwarf planet and not a planet. So the particular rules that this committee and the IAU came up with is that a planet has to satisfy 3 different criteria. First of all, it has to be in orbit around the sun. Second of all, it has to be massive enough so that it's round. So that sort of distinguishes planets and dwarf planets from things like asteroids that are very low mass and have irregular shapes, since they're not massive enough to sort of make them collapse into these roughly spherical things. And then the third criteria, which is particularly relevant for Pluto, is that it has to clear its orbital pathway. So it has to be kind of the most massive object that's in its orbit. And this is the problem for Pluto and what distinguishes a planet from a dwarf planet. Planets and dwarf planets both orbit the sun, and they both are big enough to sort of be pulled into these rounded spherical shapes. But dwarf planets do not clear their orbital pathway. And Pluto in particular crosses into the orbit of Neptune, so it is not the biggest thing in its orbit. It doesn't clear its orbital pathway, and it classifies it as a dwarf planet, unfortunately. So I know this caused a lot of controversy back in 2006, and this controversy is still here today. Lots of people, Ariella, if you're listening, believe that Pluto should still be a planet. Because, you know, it was classified as a planet at one point, but unfortunately then got reclassified thanks to the discovery of things like Eris and Makemake. So this is it's definitely a really interesting discovery. It's cool on its own to find these interesting things in our solar system. We can learn a lot about them and about the history of our solar system. But Eris and Makemake in particular are pretty important things in astronomy, because they really did lead to, like, the first solid definition of what a planet versus dwarf planet is. So overall, a very interesting date in history.
So it's all Eris's fault, is what I'm hearing.
Yes. That name was just so perfect. The goddess of discord and strife.
Yeah, a little on the nose.
Oh yeah.
Yeah, I remember. This is probably, like, when Pluto got demoted, it was probably the biggest single astronomy-related news event that I think happened in my life.
Yeah.
Because I was only 8 when, not to date myself, but when this happened, and it was like, I remember it being all over the news. Everybody was talking about it. My teachers were talking about it in class. Everybody was talking about it at school. People were picking sides. People still have sides. Just a huge thing. Yeah, notably Ariella, our boss, former boss emeritus. She's definitely on the Pluto side. She's gonna boycott us because we're saying this, actually. But yeah, no, it was a lot. And also another thing that surprises me is you mentioned that Pluto crosses Neptune's orbit. So for a brief period of time, it's the 8th thing from the sun. not the 9th.
Yeah.
And by thing, I say that generally because I don't want to make anyone mad. Um,
Yeah, that's a good idea.
but I'm a little surprised. Um, does that mean Neptune doesn't clear its path?
Neptune is the biggest thing in its
Oh, but
orbit.
it's the biggest thing.
Yeah,
Understood. Understood. I'm
yeah,
surprised Neptune hasn't like eaten Pluto then. At least kind of taken it up as one of the moons, but I guess the opportunity never arose where they were close enough for that long.
yeah, I guess. That would be interesting,
Interesting.
though. It goes from planet to dwarf planet to moon.
Just really dropping down the ranks.
Yeah.
Really bad at its job, Pluto. Just
Oh,
getting
yeah.
demoted and demoted again. Well, okay, we'll make sure to cover that on another York Universe if that happens. That'll be our entire news event is going to be that
Yeah, Pluto
thing.
demoted once again.
Oh. It's gonna now that's like a third team we're adding to the mix here. Discord and Strife is gonna be unreal.
Oh, yeah. Oh, yeah. So, like, what team are you on? Pluto planet, Pluto dwarf planet, Pluto moon.
It's too much. I can't handle it.
Yeah, that would be funny. But yeah, still definitely a very real controversy even today. Um, People are not happy about this reclassification.
Oh, entire rooms of people can be divided just based on this one question.
You should ask that at like some planetary science conference. Go to the left side if you believe Pluto's a planet, and the right if you believe it's a dwarf planet, and just see what arguments break out. That would be fun.
Oh, you know what? Next time we do that, I don't know if the Science Center still runs that planetary science convention for kids,
I'm not
but
sure.
that would be it was the one I think the last time I helped out with that was in 2019. So I'm not sure if they ran that after the pandemic. But we had this planetary science thing. Actually, trying to remember who led the project for York's team. It was oh gosh, I'm forgetting. She was our interim coordinator for a semester. Carissa?
Yes, Carissa. I remember
Her.
Carissa. Yeah.
Yeah, so there was like a whole planetary science exhibition where they were having kids design rovers, and then they would compete against each other to see if these theoretical rovers would be the best to explore a specific planet. But it would be great to just stage a debate about Pluto's planetary status.
Yeah. Yeah, because one of the interesting things is like a lot of like this rule that the IAU implemented about what is a planet versus dwarf planet was just entirely made up. Like I mean maybe saying it's entirely made up is not fair, but the whole purpose of that committee was to come up with these guidelines and figure out whether or not Pluto would stay a planet. And one of the options could have been literally just to say, well, yeah, Pluto's a planet, but the others aren't because we say so. So it's
Someone at that meeting had like a personal vendetta against Pluto.
yeah,
We'll never know their name.
oh yeah, they just led the charge. No, I don't like Pluto. It's too faint. Can't see it with the naked eye, and it's not a gas giant, so it's not a planet anymore.
How rude of them.
Even though Pluto has a nice big heart on it, it loves us.
It loves us, and it we could never love it back enough.
I think Pluto still gets a lot of love, even as a dwarf.
That's true. It's
Yeah.
probably arguably one of like the most loved planets,
Oh yeah, yeah,
besides maybe Mars.
yeah. Then that's speaking of Mars,
Oh yeah.
you have
We're
another
next.
yeah, a cool Mars news story or history item for us.
Absolutely. So this is pretty recent. 2020. I'm sure we all remember that time. Um, NASA's Mars 2020 mission was one of the three major missions to Mars that were launched that summer, along with the UAE's Hope Orbiter and China's Tianwen-1 mission. So Mars 2020 by NASA was launched on July 30th, 2020, at the height of the pandemic, and included the Perseverance rover as well as the aptly named Ingenuity helicopter. The mission's launch was quite a story of perseverance itself for NASA, as aiming for a really narrow launch window to Mars was of high priority, because launch windows to Mars come around once every 2 years, about a little over that. So if NASA didn't get this craft launched, it wasn't going to launch for another 2 years. So they had this really narrow launch window, and also a global pandemic to contend with, because at the time COVID-19 was kind of making its initial rounds. Everything was shut down. A lot of us were at home and not working. I know York shut down for a solid period of time, and none of us were allowed on campus to observe. So we only had remote observing for a while. So this put a little bit of a hamper on testing and pre-launch activities, as you can imagine. There were limits on, who could be in certain rooms and things like that. So a pretty big challenge for NASA to pull off this launch. But regardless, they managed to launch it just 8 days later than the originally scheduled launch date, within the ideal launch window. So it was a great success on that part, and it's been a great success since. Its main mission objectives, like a lot of Mars missions recently, revolve around establishing Mars as a habitable space for humans. So it's spent its time so far exploring the Martian surface, looking for signs of habitability, such as water, biosignatures, such as signs of other old microbial life. And it's also been putting away samples of rock for later testing and looking at oxygen levels in the atmosphere at different places. So Perseverance is doing a good job roving around the surface of Mars. And it also, like I mentioned earlier, has a little robotic helicopter aboard the rover called Ingenuity. So Ingenuity was basically a baby robot helicopter that launched off of Perseverance, had a camera, and did several successful launch flights from the Martian surface, and it landed back into the rover. So overall, a super successful mission. We heard a lot about it in 2020. It's still doing its thing. Ingenuity is no longer functional, but it did have flights beyond the planned mission duration. So overall, been a pretty good mission, and it was quite a feat that they managed to launch it within their originally planned window, despite everything that was going on that year.
Yeah, I didn't realize that Ingenuity had stopped working. Since when did that?
I think it was only planned for a few space flights.
Yeah.
Okay, so it was actually only planned for a few space flights, and its most recent one was April 27th, 2023. So actually it's been flying, but it hasn't had one since.
Okay. Okay, yeah, because I know the original plan was for like 4 flights.
Yeah, and
But
it's just been an overachiever.
yeah, yeah. Yeah, I mean, it with it surviving the 4, it's kind of like it just makes sense that NASA's just gonna fly it until it like dies. Because I mean, Perseverance itself is a really awesome mission, but the helicopter is really remarkable. Like some of the amazing things you can do with a helicopter on Mars. So yeah, it's definitely sad to hear like it wasn't flying.
Well, you know what? I might be mistaken. I know it hasn't flown since then, but I don't think it's not flying, if that makes sense. Like they might
Yeah,
just not be doing it right now.
just like in between.
Perseverance, yeah, Perseverance is also kind of in rough terrain as of March. So apparently in the canyons, it's difficult to get it to fly it without out of range of the rover, without the terrain getting in the way. So that might be why we just haven't heard many flights recently.
Yeah, that makes a lot of sense. But
Yeah.
yeah, Perseverance is really really an awesome mission. I remember watching the launch in 2020.
Yeah.
It really was like a great sort of few months for Mars around that time. because there was so many Mars stuff happening. Like you said, like there were two other probes that launched to Mars around that time. So, a lot of Mars in the news around around
Yeah.
July 2020.
Yeah, and it's all the other missions were also successful. So it was like a really great little period of success for these missions.
Yeah,
And they're planning further helicopters for other Mars rovers for sample returns and other, flight-based um, things that we can use. So it would be pretty great because that really expands the rover's range. It can go and collect samples without actually traveling a very specific path.
yeah. Yeah, and I know one of the interesting things Ingenuity was able to do is to help scope out like possible locations for the rover for Perseverance. So
Okay, yeah.
like that's just another great thing, you just send the helicopter if you're thinking of going to an area, check it out, get a closer look, then you can get on the satellite images and like see if it's interesting. So,
Yeah, because sometimes the satellite images are a little deceptive. Terrain looks super smooth, easy to traverse, and then you get down there and it's really rocky and, you know, Perseverance is big, but it's not that big. So
yeah,
there's a lot of terrain that's difficult for it.
yeah, exactly. So, Ingenuity is just Mars helicopters in general can be like such a great asset on on Mars flights.
Oh yeah. All
Yeah.
right. Well, I think we're a little past halfway as we generally are.
Yes.
Um,
So,
but do you want to start us off with the reminders?
sure, yeah. So just quickly before we do that, for anybody who's just tuning in, you've been listening to York Universe, broadcasting live from the Allan I. Carswell Observatory at York University in Toronto, Ontario, Canada. You can visit our website, yorku.ca/science/observatory, to make your way over to our YouTube OPV chat, where you can ask questions, and you can also see some, not live imaging tonight, but some archival images taken from our 1 meter telescope. You can also connect with us on Twitter at York U Observatory, where you can ask questions on there as well. You've been listening to Gagan and myself, Sana. We've currently just finished discussing some astronomy history. And we're gonna move on to a couple really cool news items in a couple minutes, but we do have two reminders for everybody today. So first of all, if you are around York University and you would like to observe with some of our telescopes, we are hosting an atrium tour on Wednesday this week from, I believe it's 9 to 10 p.m. Tickets are free, but you do need to register ahead of time so we know how many people are coming. We have an Eventbrite link set up where you can get your tickets for 9 to 10 p.m. on Wednesday evening. Just visit our website and you can, there are links to the Eventbrite site on there. Again, that's just yorku.ca/science/observatory. And we will be doing some observing with the 40 centimeter telescope on top of the Arboretum parking garage, along with a couple smaller telescopes as well. So those are definitely a lot of fun. We get to see some cool stuff in the sky with our telescopes. And one of the great things in the sky this week that you'll tell us about, Gagan.
Yeah, so if you have some clear skies around you and you're in and around North America, my apologies for anybody outside of North America. I did not check what the viewing times were like for you guys, but check out spotthestation.nasa.gov to see if there are any really great International Space Station sightings near you. So on the website, you can put in your location and it'll give you the dates and times as well as the maximum height and where in the sky the space station appears on any given night. And you can see the space station for a really reasonable amount of time. If you look outside and the space station goes by, it'll be moving pretty fast across the sky. If it's going right across overhead, it'll traverse almost the entire sky in about 6 minutes. And if the moon isn't out, the space station is usually the brightest thing in the sky. So it looks about as big or even bigger than Jupiter on a really bright day. So it's pretty easy to spot. If you have some clear skies, definitely check on over. It gives you the viewing opportunities for at least a week in advance. So I know for all of those in the Toronto area, we have a couple of really great sightings on this weekend. So this upcoming week. So Wednesday, July 26th, there's a pretty great viewing opportunity as well. as Thursday, July 27th. There's two pretty great overhead flybys of the ISS. So check that out if you're interested.
Yeah, yeah. ISS is definitely, I think, it's got to be one of the best things to see, partly because you can see it from anywhere, even in a city.
Yeah.
So it's a really awesome thing to look at.
Yeah, it doesn't need to be because it's so close and so bright. You don't need to be in a dark sky area. It honestly, the sun doesn't even have to be totally down. Like you can see the ISS probably like just after sundown. So the sky's still bright, but the ISS will be brighter.
Yeah.
Okay, so Sana, do you have our first news item for today?
Yeah. So this is a really cool discovery of the of a galaxy that I'm surprised didn't get picked up by like space.com or something. So this is just a news story that I've pulled off of the archive where people always post their papers. But this is really, really cool. So it's the discovery of, and I'm going to say the sentence and I'm going to explain it, of the lowest mass and most distant environmentally quenched galaxy that has ever been observed. Of course, observed by JWST. So when I say quenching, that just refers to the process of how galaxies shut off their star formation. So galaxies do spend a lot of their lives forming stars, converting cold gas into stars. And eventually, a lot of the time, something happens that disrupts that conversion of cold gas into stars, primarily by heating up that gas or ejecting it from the galaxy or preventing the galaxy from accreting or gaining more cold gas. And that process is referred to as quenching. Now, there are a lot of different things that can cause a galaxy to quench. Some of these things have to do with environment, called environmental quenching. So there are things that are happening outside of the galaxy that's causing the galaxy to quench. And I'm being completely serious here. These are the actual technical names for these processes. They are called stripping, harassment, strangulation, and what was the last one? Cannibalism. So those are the actual names, like scientific terminology for some environmental quenching processes. And a lot of these just have to do with how cold gas gets removed from a galaxy due to some interaction with either gas that surrounds the galaxy or with other galaxies nearby. So just the way that the galaxy interacts with its environment. You also have another kind of quenching called self-quenching, or also called mass quenching, which is when something happening within the galaxy is what's causing the galaxy to shut off star formation. So these can primarily be things like if a supernova goes off in the galaxy, it ejects energy into the galaxy so it can heat this cold gas and prevent it from forming stars. It can even eject some of that gas out of the galaxy. Another very common self-quenching mechanism is a supermassive black hole at the center of the galaxy. Those are really energetic systems, and they often do the same thing that supernovas do. They can actually stop a galaxy from forming stars by heating up the cold gas and ejecting it out of the galaxy. So there's been a lot of different examples of galaxies that have been quenched by environment or by themselves. But overall, studying quenching in galaxies, particularly environment quenching, is quite hard because galaxies that are quenched by their environments tend to be low mass. Very high mass galaxies, which are the ones that are easy to find because they're a lot brighter, tend to quench mainly because of something like the supermassive black hole in their cores. It's something going on within the galaxy itself that causes quenching. But environment quenching, because it happens in lower mass galaxies that are more easily influenced by their environments, it can be really hard to study. And that's why this detection of this galaxy is really cool, because it's a very, very distant galaxy, the most distant one of the most distant galaxies detected, that's also very low mass and is quenched by its environment. So the galaxy itself, as usual, has an absolutely terrible name. It's called JADES-GS-53.12365-27.80454. The first part of it, called the name JADES, stands for the JWST Advanced Deep Extragalactic Survey, which was the survey that had the imaging of the galaxy and also took a spectrum of the galaxy that identified it and studied it. GS just stands for the field that it's in. It's in a field called Goods South, which it's a pretty famous field. It's been studied by a lot of different observatories, which is part of the reason why JWST observed it. And then the numbers at the end just refer to the coordinates. It's right ascension and declination. But, overall, a really terrible name because nobody can remember that. But anyways, it was originally identified by the JADES team as one of the most distant galaxies in our universe. So they thought, this is a really cool galaxy. We need to get a spectrum of it. And they got a spectrum of the galaxy, and it turns out that they were completely wrong. It was not one of the most distant galaxies ever discovered. It actually exists at when the universe is around 2.8 billion years old, which that is still relatively young for our universe, considering it's currently 13.8 billion years old. For people who think in redshift like I do, this is a redshift of 2.34. But this is, even though it's not one of the most distant galaxies ever discovered, it is still a pretty distant galaxy. And it's also very low mass, which is something that you can only do with JWST because low mass galaxies are very faint. So the fact that they found this galaxy and then got a spectrum of it and found this, it turns out it wasn't not what they were looking for, but it's still this really interesting, distant, low mass galaxy. Still ended up being really cool. Now, one of the other really cool things about it, apart from the fact that it is low mass and very distant, is that the galaxy does not have any ongoing star formation. So it is quenched. It had its star formation shut off for a few 100 million years. They determined that it quenched, so no more star formation, around when the universe was only 2.2 billion years old, and it exists right now at when the universe was 2.8 billion years old is when we were observing it. So it has not had any ongoing star formation for quite a long period of time. And this is significant because this is the most distant environmentally quenched galaxy. So not only is it not forming stars, but the team was able to determine that it's not forming stars because of stuff happening in the environment. It seems it's kind of likely it's some sort of stripping mechanism where gas gets removed from the galaxy because the outskirts of the galaxy are more quenched than the center of the galaxy. So it stopped forming stars first in the outskirts of the disk and then later stopped forming stars in the center of the disk. So the fact that they found this thing, not only is it pretty remarkable, but it also has a really cool science result that galaxy environment was important for shutting off star formation in galaxies, even all the way back to when the universe was only 2.2 billion years old. So I think this is a really cool discovery of a galaxy. It really establishes a sort of timeline for how galaxies can shut off their star formation because it was discovered. This is a galaxy that exists within the first couple billion years of the universe's very, very long history. And it's also just a general interesting object to find because it is so low mass and so distant, and probably would not have been identified if it had not been mistaken for a very, very distant galaxy, which it turned out that it wasn't. But yeah, definitely really cool, and hopefully there'll be more science to come out of this JADES-GS bunch of numbers and other galaxies like it to kind of fully solve this question about what is mainly responsible for shutting off star formation in galaxies. Is it environment, or is it something that's happening in the galaxy itself?
Those names are always so fun. Quenching, strangling.
Yeah.
What were the other ones?
It was strangulation. I don't know if I mentioned starvation. Starvation's another one. There's cannibalism.
And the thing is, they make sense. Like, when you think about it, okay, starvation. Yeah, there's nothing left for more star formation. So, yeah, the galaxy's going to starve.
Yeah, and stripping is literally like stripping gas out of a galaxy and just removing it. Which makes, by the way, it makes things called jellyfish galaxies.
Oh.
Awesome. They are super interesting, and another interesting name of galaxies from astronomers.
Yeah, I love it.
Yeah. Yeah, well, that was definitely an interesting galaxy, but you have a really cool news story.
Yeah, and I'm actually not going to tell you guys what it is until I get to the actual bit that's going to throw you guys for a little loop. But I'm just going to start off with, it's about moon exploration and how to make it more efficient. So moon dust is a really annoying phenomenon. It's a charged, superfine powder that sticks to spacesuits, and it very stubbornly doesn't let go. And it's proven to be pretty damaging to spacesuits while on the moon. There isn't any wind to blow the moon dust away, and it's a pretty abrasive powder. So when astronauts in the Apollo missions tried to brush it away with these designated brushes that were made for getting moon dust off the suit, it actually led to some seals not functioning properly, which can cause leaks in astronaut spacesuits. And as you can imagine, that's pretty concerning when you're almost 400,000 kilometers away from a breathable atmosphere. So a research group at Washington State University has been putting Barbies to work in figuring out how to solve this moon dust problem. So these Barbies are girl bossing, they have jobs. What they're doing at Washington State is they get dressed up in their little bespoke Barbie spacesuits, and these are made with fabrics and materials that are used in actual real-life spacesuits. And the Washington State research team sprays them in homemade moon dust, which is basically just superfine volcanic dust from Mount St. Helens, which acts in a very similar way. After that, they tested out different ways to get the moon dust off the Barbies, off the spacesuits, and they found that spraying them with liquid nitrogen was the most effective way to get the moon dust off the Barbies while minimizing damage to the spacesuits. So they bring Barbie around to their conferences where they present their research, which is so fun. I'm just imagining what a great little conference presentation that is. Like, they must win first place every time. And it wouldn't be the first time Barbie has contributed on a space mission. 2 space discovery Barbies were recently aboard an expedition to the ISS. So the Barbie moon dust experiment was a pretty big success, and while the Washington State University group's research is probably going to move on to testing life-size spacesuits on life-size people, I'm looking forward to seeing how Barbie lends a hand in space research in the future, because that's a pretty fun little anecdote.
Yeah, especially with the all the publicity around the Barbie movie.
Oh yeah.
This is the perfect time for a story like this.
I know. I haven't had the chance to go see it yet, but almost everybody was a Barbie kid at some point when they were younger. It was just a great time. There's Barbies for everybody, Barbies with every job, and including astronaut Barbies. Astronaut Barbie actually went into circulation, I think, 13 years before NASA started hiring women as astronauts. So talk about ahead of the game. Like, Barbie's had it made.
Yeah, that's awesome, and really cool research too. So
yeah, I was surprised to hear about like the abrasiveness of moon dust, but it actually, when I read a little more on it, I realized that it makes a lot of sense, because a lot of the time dust, rocks, particulate matter on Earth, say in a riverbed or out on the desert somewhere, they get kind of rounded off by erosion. So the wind will carry sand particles, and they'll bump into each other a bunch of times, and they're in motion on Earth because of the elements, and so they get eroded into round, soft pieces of sand and dust. But on the moon, there's no element that allows for erosion to occur. There's no wind, there's no water. So the moon dust basically was created, and then it stayed in that exact position forever. So you don't get any of that rounding off of the sediments. So what you get are these really sharp pieces of dust that cause tears and really challenge the integrity of the fabric of spacesuits.
Yeah, that must be difficult to breathe.
Oh yeah.
Like, getting everywhere like that. That must have been a very tough, coughing fits on the moon. I wouldn't be surprised if there were a few of those.
Yeah, and actually the research group, they mentioned that one of their next steps here is getting the moon dust out of the air before the astronauts have to get out of their spacesuits. Because if you can blast the astronaut at the airlock of a habitat and kind of blow the moon dust off of them, well, where do they go then to take off their spacesuit? Because there's moon dust all around the atmosphere.
Yeah. So definitely, yeah. super important research for future moon travels that will hopefully be happening soon with the Artemis missions. But we are just about done here. So you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Gagan and myself, Sana. Stay tuned because it is Science Night in Canada, coming up with Western World, Quirks and Quarks, and Science for the People. Remember, you can always connect with us on Twitter at the handle @YorkUniverse, on Instagram with the handle @YorkView Observatory, and on Facebook at Allan I. Carswell Obs. Also, don't forget to check out our website for show notes, content, updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in, clear skies, and have a good night.
This is Astronomy.fm radio.